Clear water is described as crisp flow of a clear creek cascading down a steep mountainside and the refreshing glass of ice water on a hot day. It encompasses the spring-fed brook filled with wild-throat rain nourishing a parched field, lush wetlands teeming with life, and dynamic estuaries thriving with healthy aquatic species. Clean water is vital for all aspects of life. It sustains drinking, bathing, cooking, swimming, fishing, boating, food growing and processing. It nourishes not only plants and animals but also soothes the human spirit with its aesthetic beauty. Chapter 1: The Water Environment. Clean water is vital for drinking, agriculture, industry, and ecosystem. It exists in various natural forms such as rivers, lakes, wetlands, and oceans, each influenced by factors like geology, climate, and vegetation. However, human activities, especially industrial, municipal, and agricultural pollution, are major threats to water quality. The hydrological cycle connects all water sources through evaporation, precipitation, runoff, and infiltration, which can also spread pollutants. Water pollution, both points and non points, introduce harmful chemicals, nutrients, sedimentation, and pathogens, reducing water ability to support life. Wetlands act as natural filter but are endangered by development. Protecting water resources require understanding the water cycle, controlling pollution, enforcing regulation, and promoting community involvement. Clean water prevention is a shared globally duty essential for life and well-being.
Chapter 2: Water Chemistry and Microbiology. Water's composition and quality. Water exists as a liquid, vapor, or ice and is an excellent solvent naturally containing dissolved salt, minerals, and organic matter. Number 1: Dissolved oxygen. Essential for aquatic life, higher in colder, faster water. Number 2: Temperature. Effect: dissolve oxygen and can cause thermal pollution, harming organism. Number 3: pH. Most natural waters are between 6.0 and 8.5. Extreme pH from industrial waste must be neutralized. Pollutants and effects. Organic substances increase BOD and COD as they decompose, reducing available oxygen. Inorganic substances or solid include hard water minerals like calcium, magnesium, toxic heavy metals, and suspended solid causing turbidity which blocks light. Nutrients: excess phosphorus causes eutrophication, while high nitrate in drinking water is a hazardous, especially to infants. Water bodies are classified as oligotrophic, mesotrophic, or eutrophic. Toxic substances. Chemicals like pesticides, ammonia, dead poison aquatic life. Their toxicity is tested by bioassays and can be acute or chronic. Microorganisms. Bacteria decompose organics but can spread disease, cholera, and typhoid. Algae support the ecosystem but can overgrow and reduce quality. As you know that we are discussing water pollution, so my 3-4 chapter based on sources of water pollution and its prevention. Water pollution remains one of the most pressing environmental challenges globally, with a variety of sources contributing to the contamination of freshwater resources, stormwater runoff, domestic discharges, septic systems, sewage treatment plants, industrial discharges, accidental spills, and water control structures all play significant role in polluting water bodies. These pollutants, ranging from chemicals and pathogens to nutrients and heavy metals, pose serious risk to human health, aquatic ecosystem, and overall water quality. To address water pollution effectively, prevention is key. Natural water pollution control processes such as wetland filtration and vegetation buffers can help mitigate some of the impacts of pollution. However, human intervention is necessary to reduce pollution at the source. Stormwater treatment, domestic wastewater treatment, improved septic systems, and effective sewage and industrial wastewater management are all crucial steps in minimizing contamination. Additionally, spill prevention strategies and rapid response to accidental discharges play an essential role in safeguarding water quality. Overall, the chapter highlights that protecting water quality depends on responsible management, technological improvement, and community awareness. By reducing pollution at its source and strengthening treatment and prevention efforts, we can preserve safe, sustainable water sources for the future.
Chapter 5, Water Quality Regulation. The Water Quality Regulations outline major U.S. laws that protect and preserve water resources. The Clean Water Act of 1972 focuses on maintaining the integrity of the nation's water by setting goals, funding sewage treatment projects, establishing water quality standards, and allowing legal action against polluters. The Safe Drinking Water Act of 1974 protects public health by setting limits for contaminants like nitrates, benzene, and coliform bacteria in drinking water. The National Environmental Policy Act ensures that federal agencies assess and document environmental impacts, consider alternatives, and implement mitigation measures before taking major action, promoting informed and transparent environmental decision making. The U.S. Water Quality Regulations outline federal and state efforts to protect water resources, manage hazardous waste, and preserve wetlands. The Resource Conservation and Recovery Act governs hazardous waste generation and handling, but was insufficient for cleaning up past contamination, leading to the creation of Superfund program to locate and clean abundant hazardous sites, though it's costly and often disputed. Responsibility for implementing water quality laws is largely given to state agencies which manage programs like National Pollutant Discharge Elimination System, requiring permits for industrial and municipal discharges that specify limits, monitoring complaints, and renewal conditions. States also set water quality standards defining acceptable chemical and physical conditions based on a water body's use, and for polluted water, they establish total maximum daily loads to regulate pollutant input. Wetland protection under Section 404 of the Clean Water Act requires permit for discharging materials into U.S. waters administered by the Army Corps of Engineers with state oversight through Section 401 Water Quality Certification to ensure compliance. Additionally, state environmental policy acts parallel the federal NEPA process requiring evaluation of environmental impacts from state and local projects to maintain water quality. The final section explains how local governments protect water quality through construction ordinances, floodplain rules, and special districts. Construction ordinances require erosion controls like sediment fences to prevent runoff, while floodplain ordinances protect wetlands and reduce flooding. Special districts such as those for Devil's Lake and Puget Sound focus on improving water quality in specific areas. The section also reviews key federal laws, the Clean Water Act and Safe Drinking Water Act, and concludes that despite these regulations, many U.S. waters remain polluted, introducing watershed management as the next solution. Chapter 6, The Watershed Approach. The watershed is a drainage area where all rain or snow melts flow downhill to a shared water body like a river or a lake. Its boundaries start from ridges or mountain tops and extend to the lowest point, containing all landforms, vegetation, and water bodies within it. Large watersheds consist of smaller sub-watersheds and all human and natural activities within a watershed such as farming, urbanization, flooding, or erosion affect water quality locally and downstream. The watershed approach is a comprehensive cooperative method of managing water quality by addressing all pollution sources within the watershed rather than treating them separately. The goal is to achieve overall watershed health efficiently. If we talk about the benefits of watershed approach, so it prevents isolated solutions from being undermined by other pollution sources. It encourages collaboration among citizens, scientists, and policymakers. Coming towards the key steps in the watershed approach, the first key step is characterize the watershed. Study physical, chemical, and biological features using tools like GIS. Number two, identify activities affecting water quality, that is, to examine land uses and natural events impacting water. Number three, develop alternatives. Propose solutions for both point sources and non-point sources using best management practices. Number four, select and implement best options. Involve stakeholders, set clear measurable goals, and ensure local support for long-term success. Number five, monitor and adjust. Collect data, track progress with water sampling and biomonitoring, and revise plans as needed. The process is continuous and adaptive, with improvements in water quality often taking many years to appear.
Chapter 7, Drinking Water, emphasizes that our drinking water sources come from surface water and groundwater within watersheds, which are interconnected through the hydrological cycle and are subject to various natural and human caused contaminations. The chapter outlines the extensive treatment process necessary to ensure drinking water safety, includes removal of solid microbial contamination control and adherence to drinking water standards and regulations. It highlights ongoing concerns such as microbial contamination, chlorinated organics, and toxic matter like copper and lead. The chapter stressed the importance of maintaining drinking water quality to protect public health and the environment by controlling watershed disturbance and contamination source.
Chapter 8, Getting Personal About Clean Water, focuses on a personal responsibility and practical action individual can take at home to protect water quality. It encourages the use of environmental friendly cleaning products, wise use of household water and energy, composting, recycling, and proper maintenance. It highlights being mindful of pesticides, herbicides, and fertilizers, use in home landscaping, and managing runoff from private properties. The chapter also promotes educating and involving family members, especially children, in water protection efforts. Public involvement through environmental organization and other community activities is presented as essential for sustainable water quality. Ultimately, individual action combined with community efforts play a vital role in maintaining clean and healthy water. We get this message from this book is take personal responsibility by practicing water conservation, reducing pollution, and supporting sustainable practices in daily life. Thank you.